So welcome back guys. Today we were discussing about writing a same query in both the format like in SQL as well as in Pandas. So I have taken a question so-called average selling price. In this question I was given with two tables, prices and units sold, and I need to rectify the average prices sold of the product where the purchase date should lie between start date and end date. So when I have written it in the SQL method, it has worked perfectly fine, and it is already I have solved in SQL. So now I will be solving the same query using Pandas. So how do we start in Pandas? So for starting, we have to join the tables. So I prefer dot merge as the table as the function, and then units sold how equals to left. Why I have used our left join? Because we need to retrieve all the products present in both the columns, in both the tables. Now, my first thing is I need to sort this product in a way that the purchase date should always fall between start and end date. First part. Second, as we know, when we will use the left join, we will come across the null values. So what do we do with the null values? So we have to firstly identify them, and then we have to fix something called null in our data set so that the null will be visible to the audience. So for that, let's fix the null part first. Okay. So df of purchase date is NA, or df of prices, sorry, it is should be purchase date again, right? Purchase date is greater than equals to df of start date and df of purchase date is less than equals to df of end date. So what I have done here is I have given a condition. So my condition is this way, that if the purchase date is between start and end date, then show them, otherwise leave them. Because we just need the purchase date which are between start and end date according to this query. And I will make them as a data frame. So another square bracket and df. Yeah. So just return df and see how our table will look like. So this is how the table is looking like. Okay. So this is the first table. This is the second table, prices and units, prices and purchase dates and units. So purchase date and unit. So it is joined on the product ID. Then this part is clear. Now let's move to the aggregation part. So for the aggregation part, I will use now lambda function over product ID dot apply lmbda lambda x, where sum of x of, okay, so let me explain you why I am doing this. Because according to this question, how they have calculated the average prices, they are multiplying the units with the prices. So 100 into 5 plus 15 into 20 divided by 100 plus 15. So this is what they have done. 100 into 5 plus 15 into 20 divided by 115. So how can this come together? Because they have the same product ID. So I will do the same thing over here. I will just do sum of units into x of price divided by sum of x of units, and I will reset the index and name it as average price. So let's run this part first. So you can see we have gathered this part. Okay, so I'll just put another function here, round up to 2. Round up to 2. Now you can see it is accepted, and when I submit this I will get a wrong answer. Let me show you why. See, so let's use this test case. So for this test case, when we are using test case 2, because of this factor, you can see here our product, because in this product, this test case, they are having test case number 15, they are having another product called product ID 3, which is not there over here. Okay, so if the product is not there, then we need to show it as null. So I will use another function here. So fill NA with 0. So this has come. Okay, now you will be thinking why round function is not working here. So round function is not working because it is not rounding up the numbers present in average price column. Okay, so what we can do is we'll just take this round out from this, and then we will do this way of average price equals b of average price dot round of 2. Now let's run the query. So you can see it is working now. So for both the test case it has worked, and I'll just submit this part. And it is finally it is working perfectly. So this is what we can do with the pandas as well. Now I will show you another question with pandas. So the question says I need to get the project. The question is project employees 1. The main query over here is average experience years of all employees for each project. So how they have calculated the average experience? So they have calculated average experience as count means sum of the experience divided by sum of the employee ID. Okay. So employee ID is 1, 2, 3 and 4. So there are different employee ID, but you can, okay, some they have calculated it this way, I think. So count of project ID. Yes. So count of project ID they have done, because 1 plus 2 plus 3 is what they are doing at the first, and then they are dividing it with 3. Okay. So this is the question, guys. So let's solve it in the similar pattern. So df.pd.merge, and we will merge the project, comma, employee, comma, how equals inner, because I don't want any null over here. If it is required, then we will be looking them at in the later stage. So df equals to df dot group by project id dot apply lambda lambda of x, where we will sum x of experience. Yeah, I just copy this thing so that it's not an issue, divided by, okay, in this part in pandas we don't have exceptional function called count thing, because it will not directly count it will not exactly count because count always includes the numbers, and it never goes with the it never goes with our null values. It will never count the null values. So there is another function called size. So we have to use size over here. So for using the size, what we can do is uh, okay. So there are three functions in pandas. I will just help you note them out. N unique is a function that will calculate the unique values present in the table. Second is count, and third will be size. Okay. So what's the key difference over here is this will n unique will always count the number of like total number of the values present in a data set. For example, employee ID is having 4 values, so it will show 4. Again, count will also show 4 because there is no null values, and size will again also show the 4. So there are three functions. You can always remember them because they are very highly used in the day-to-day work. So we will do here is dot project ID dot size dot reset index name equals to average years. Hit return df. Let's see what it shows to us. So key error is project ID. So let's use another function in unique and then run this. 6 and 5. Okay. Uh, Let me just do this way. So it is accepted. So what I have done here is it was, as in the question, it was divided by 3. Divided by 3 means we are dividing by number of employees, and they have also mentioned here in this way average experience years of all employees for each project ID. So for all employees they have mentioned, so we have used this thing. Okay, now let's just round them up. df of average years, I just copy this and paste it, round up to 2 decimal points, and I will submit this. So I think so we have to deal with the null values, even though there was no null value because we have used the inner join. So yeah, it is working. So bits is 87. So this is how you can solve the question, and later stage we will be solving few more questions and I will show them and record them as well. Thank you.